Right now, I think one of the hottest topics that's being discussed in the entire internet is YR4 2024, an asteroid that may hit Earth in 2032 and may wipe out a huge number of human beings from the surface of Earth. But what's the update? The story begins in December 2024. A team of astronomers made a startling discovery, a previously unknown asteroid, now known to have the potential to cross Earth's orbit in 2032. This was not just another distant space rock. Initial calculations painted a worrying picture, suggesting a non-negligible chance of a collision with our planet. But immediately upon discovery, the asteroid raised red flags. Its potential impact risk earned it a rating of 3 on the Torino scale. This scale, used by astronomers to categorize the potential threat of near-Earth objects, indicated a greater than 1% chance of collision and a size sufficient to cause localized or regional damage. Okay, please listen carefully. I repeat, it is a small object. Pretty small that even if it hits Earth and survives the atmosphere, then it can only cause small localized damage. The early odds were estimated at a concerning 1 in 80, though the chance was little, but this was alarming enough to become the most dangerous known asteroid to us at the time. Before moving to the main part, I'd like you all beautiful people to subscribe and ring the notification bell. I had not posted any videos since September 2024 as I was going through a major life event. I got married and there were a lot of work and a lot of hassle. If you're married too, I know you'll understand. Anyways, I promise to be regular here from now on. Thank you everyone. Now, coming back to the story. Astronomers knew they were in a race against time. By April 2025, the asteroid would pass behind the Sun, rendering it virtually invisible to telescopes until its reappearance in 2028. To refine the initial orbital calculations, scientists launched a two-pronged investigation, searching for predictions in achievable telescope data, acquiring new observations. The search for predictions was a cosmic scavenger hunt. Researchers meticulously shifted through older images captured by various telescopes, hoping to find faint traces of the asteroid from years past. If successful, these prior observations could significantly extend the observational baseline, leading to a more precise understanding of the asteroid's trajectory. However, the initial results were discouraging. A search of Subaru telescope data from 2016 came up empty. While seemingly insignificant, these non-detections added to the uncertainty surrounding the asteroid's path. Despite the setbacks, hope emerged from the Gemini South telescope in Chile. This powerful optical instrument successfully captured an image of the elusive asteroid using a long exposure technique focused on the red band of the spectrum. The 12,000 second exposure revealed the asteroid's faint presence, enabling scientists to track its motion and refine their orbital estimates. The new data from the Gemini South was fed into NASA's Near-Earth Object Tracking System, leading to an updated trajectory calculation. This is where the story took an unexpected turn. Instead of decreasing, the estimated probability of a collision began to creep upwards. Over the following weeks, the impact probability rose from 1.3 to 1.8, then 2.3%, ultimately settling at 2.6%. While still a relatively low number, the increasing trend heightened concerns within the astronomical community. Despite the improved data, challenges remained. The asteroid was a faint object receding rapidly from Earth, making precise measurements difficult. Furthermore, the observations were hampered by a 70% illuminated moon, which increased background light and the potential for error. Based on the available data, scientists began to piece together a profile of the asteroid. By analyzing its brightness and how that brightness changed as it rotated, they were able to glean some valuable insights. Number 1. Shape. The asteroid appears to be elongated, suggesting an irregular form. Number 2. Rotation. it has relatively rapid rotation period, approximately 20 minutes. Number 3. Size. Estimates placed its diameter between 40 to 90 meters, 130 to 300 feet. This puts it significantly smaller than Dimorphos, the asteroid targeted by NASA's DART mission, but still large enough to pose a significant threat upon impact. Now let's understand the potential impact scenarios. If the asteroid were to impact Earth, the consequences would depend on its size, composition, and point of entry. Based on current estimates, the potential impact energy is estimated at 8 megatons. A direct hit could produce an explosion comparable to the Tunguska event or leave behind a crater similar to the Barringer crater in Arizona. However, scientists believe the asteroid is likely composed of stony materials, possibly S-type, L-type, or K-type. If this is the case, it would probably disintegrate in Earth's atmosphere, resulting in an airburst. While still potentially damaging over a wide area, an airburst would be less catastrophic than a direct impact. Now, the impact potential that we previously discussed to be around 2.6% had increased to 3.1%. But just a few days ago, NASA changed their estimates to 0.3%. There was a very slim chance that the asteroid will collide with the moon. While posing no direct threat to Earth, such an impact would create a visible crater on the lunar surface, potentially observable through binoculars. There is a greater chance of the asteroid passing through the gap between Earth and the moon also. But today NASA has changed the chance to hit Earth to be 0%. The story of this asteroid is far from over. The next crucial step hinges on observations from James Webb Space Telescope. If JWST can observe the asteroid before it disappears behind the Sun in April 2025, the data could significantly refine its trajectory. If JWST observations are not possible, astronomers will have to wait until 2028, when the asteroid reappears from behind the Sun. At that point, a more accurate assessment of the impact risk will be possible. If the collision probability remains high after the 2028 observations, the possibility of a deflection mission would need to be seriously considered. Given the asteroid's relatively small size, a DART-like kinetic impactor mission could be a viable option. For now, there is no need to panic, for the most likely scenario remains a close passage between Earth and the Moon. However, this episode serves as a valuable reminder of the ongoing need for vigilance and investments in planetary defense. The universe is a dynamic and sometimes unpredictable place. By continuing to monitor the skies and develop technologies to mitigate potential threats, we can protect our planet from the future cosmic surprises. The story of this asteroid and others like it is a testament to the importance of scientific discovery and international collaboration in safeguarding our future. Thank you for watching, and please subscribe.